the specific sheet. I'll just share the Jamboard. Okay. So I hope you can recall the formulas na binigay ko last Friday regarding specific heat and the relationships between them, the ratio or specific heat ratio. So here's an example. So for a certain ideal gas, R is equivalent to 25.8 foot-pound force yan per pound mass degree runtime. So that's a standard unit for English, R, and also for CPs. And K is equivalent to 1.09 English air. So what are the values of CP and CV? Yun yung una nating hanapin. And letter B, what mass of this gas will occupy a volume of 15 cubic feet and 75 psia and 80 degree Fahrenheit. And also letter C, if 30 BTU are transferred to this gas at constant volume in the letter B, so that is 15 cubic feet, what are the resulting temperature and pressure? Sige. So let's identify the givens first for letter A. Given tayo ng R for this problem. R of a certain gas is 25.8. It's given. So foot on force per pound mass. Okay. Also given tayo ng 8 of this gas. That is 1.09. As I have said earlier on Friday, so K is unitless since CP over CB. CP over CB. Cancel lang ang unit niya. Okay. So for letter A daw, determine the CP and CB. So last time, I hope you can recall nga. So given tayo ng, sige, i-recall natin dito yung mga formulas. We have CP equivalent to CV plus R. Meron tayo yan. Also, we have formula for CP na KR or over T minus 1. And we also have the formula for CV. That is R over K minus 1. Alam nyo i-memorize to. And then lastly, the ratio na itself or the specific heat ratio, which is K. And then that is equivalent to CP over CV. Given yan as 1.09. Okay. So how do we solve for CP? As our first requirement. And so gamitin na natin this formula. So CP is equivalent to K. We have K as 1.09 multiplied by 25.8 pound force per pound mass All over k minus 1, so that is 1.09 minus 1. So therefore, when you guys compute for C2, itabas yung mga calculators natin. CP then would be equal to ilan? Can somebody dictate? Hello?
$54.4667.
So that is 54 point. Okay, ulit nga.
66. Ay, wait lang, sir. 4667.
4667 and foot-pound force per pound mass. Okay. Okay. So we already have CP for letter A. Next naman is kunin natin yung CV. So CV, we can just manipulate this formula para mas madali, hindi nyo na isa-solve ng matagalan. So we can say that CV is equivalent to CP minus R. Parang i-transpose lang natin si R papuntang kabilang side. So we can say that CP is equivalent to CP minus R. So that's equivalent to 54.4667. That was 25.8. So their units, of course, is the same. That is the input on force per on mass second kind. So ilan si CV? Nasa bandang paan din yan.
28.
28. That is 28.
0.667.
Foot pound force per pound mass strength. Okay. Meron tayong CV. Tayo sa letter B. Letter B is what mass of this gas will occupy a volume of 15 cubic feet at 75 psi and 80 degree Fahrenheit. So babalikan natin yung ating ideal gas, no? Which is, favorite natin yan, is PV equivalent to MRT. Hindi ko alam natin yung mass. Can get the mass as PV over RT. Therefore, mass be equivalent to 75 psia or pound force per square inch multiplied by, so convert na natin para maging feet squared si inches to. So 12 inches over 1 feet squared multiplied by V volume. Volume natin is given for letter B. Properties is 15 cubic feet. So we have 15 cubic feet. So over RT, given tayo ng R kanina, that is 25.8. Almost 10 multiplied by the temperature, given tayo 80 Fahrenheit. Convert natin dito properly. Cancel the units. So cancel tayo. Cancellation of units. Bigay lang tayo. Cancel out. Which is squared. Cancel. Pittsburgh na to. Mag-merge si Pittsburgh dito sa bit sa baba. So si cubic feet. Pound force will cancel out. Matitira is pound mass. Therefore, our mass for this gas so wala nakikipag-participate. So I have recomputed letter A. So it seems mali yung 54.4667. So the correct answer here is, so paki-check Mr. Kwan sa nagsabi kanina. So paki-re-input the following. So ganito dapat. 0.09 numerator multiplied by 25.8. So RCP for letter A should be 312.47 pound force per pound mass runtime. Pero dito, mag-iiba na din. So magiging 312. So 312.47. So this will be equivalent to 286.67. And for letter B naman, our mass, so that is 75. We're already done with the unit analysis. So 75 times 144, technically, since squared lang yan, multiplied by 15, all over her R, that is 25.8, divided by 80 plus 460, that should be 540. So for our mass, that would be equivalent to 11.6279. So I hope nakakasunod lahat. So may mga questions ba so far for specific heat ratio? So if wala, kindly screenshot what's on your screen for your notes. So makulit ulit ako for PP. So pag-inform naman ako pag na-screenshot mo so we can proceed. Okay. Done na. So for letter C naman, tinatanong doon is, so what are the resulting So if 30 BTU are transferred to this gas at constant volume, so what are the resulting temperature and pressure? So nag-add tayo. So, heat. Equivalent to 30. So balikan yung notes nyo. Kita nyo doon yung formula for heat addition under constant volume. So, yan. That is equivalent to M CV delta T. This is also the formula for internal energy. So, MCV delta T. Or gaya nung diniscuss ko nung Friday, pinaliwanag ko doon sa part ng specific heat under constant volume, di ba? Na technically since walang flow of energy, so lahat ng natitipon doon sa system natin is ay natitipon nga. So magkakos lang yun ng higher internal energy na nagiging heat lang din natin. So, parang ganun. Anyway, let's proceed. So we have 30 BTU. Equivalent to. Hinanap natin ito is final temperature. So, we have mass CV multiplied by T2 minus our initial temperature na 80 degree Fahrenheit. So that is 540. Yan. So pwede nating transpose this to baba. We can say that T2 minus 540 is equivalent to 30 BTU all over our mass. Yan yung letter B natin. So 11.627 679 on mass. And our CV, solve natin yan from letter A, we have 286.87 foot-pound force. per pound mass degree Rankine. Okay. So, paano natin nagka-cancel si BTU? So, from RP1, nagbigay ako ng conversion unit for BTU. That is equivalent to 1 BTU is equivalent to 778 foot pound force. Okay. So, cancel. BTU, i-cancel out. Pound mass, maka-cancel din. And foot pound force, maka-cancel. So, akyat ang unit ni Rankine. Kaya, algebra lang yan. So, denominator, magiging numerator yan. So, sa mga may calcu, paki-calcu. So, T2 minus 540 equivalent to ilan? So, that's
6 point.
sige. 6 point.
Nine nine eight eight.
6.9988. Okay. 6.9988. Rankine. So therefore, we can get the final temperature. So transpose natin. Pakalbila, C540. So we have T2 equivalent to 6.9988 Rankine. So plus 540. And so therefore, it is equivalent to 546.998 Rankine. Or we can say that it is so minus 460, we will get 86.9988 or roughly 87 degree Fahrenheit. Pwede rin ito yung answer. So, yeah, very. So any questions? Let's see if you can keep screenshot nyo na lang muna. Kasi ito sa mga bilisan na lang natin. For certain gas, R is equivalent to 320 joule kilogram Kelvin. SI tayo ngayon, not English. And CV is equivalent to 0.84 kilojoule per kilogram Kelvin. So for letter A, we are required to find CP and A. And letter B, a 5 kilogram of this gas undergo a reversible non-flow constant pressure process from, and so discuss natin to later on. So constant pressure process, this is isobaric. And from V1 equivalent to 1.33 or 1.133 cubic meter and P1 na equivalent to 690 kPa to a state where the T2 is equivalent to 555 Celsius. So find the change in internal energy and the change in enthalpy daw. Okay. So given tayo, saan natin mga given? Of R, a certain gas as 320 joule per kilogram Kelvin. We can also say that it's equivalent to 0.32 kilojoule per kilogram Kelvin. Also, given tayo ng CV as 0.84. Kilojoule per kilogram Kelvin. So, for letter A, nakakadali ng CP. CP is equivalent to CV plus R. Diretso na natin dito. So, we have CV given 0.84. Then our R, that is 0.32. Kilojoule per kilogram Kelvin ang ating unit. So, simple lang unit, kaya pinag-list ako na lang. Yan. So, ilan yan? That is 1.20, 1.16 pala. Ba? Walang nag-disagree, so tama. Kilojoule per kilogram Kelvin. Yan. Meron tayong CP. And then, of course, the specific ratio or K ratio nga. So, that is the CP over CV, or the ratio of CP over CV. And so, nasolve natin sa CP as 1.116. We have CV that is given 0.84. So both are in kilojoule per kilogram Kelvin. So makakancel lang din yung units na yan if i-input natin dito. So right now natin yung CP over CV. We will get a value for K or our specific heat ratio as parang din dito.
1.38110.
Okay. Thank you. So we have 1.3810. Okay. Okay. Okay, tapos na si letter H. So for letter B daw, what is the change in internal energy and the change in enthalpy? Given na nag-undergo siya ng constant pressure process with this following properties. So very common sa mga thermodynamic processes. Sa CP, I think na lalaki pa ata ito ng private. So for under CP or constant pressure na specific heat, ang makukuha nating value doon is with enthalpy. And pag CV naman, so mass times CV. Natin ang triangle dito. Delta of the change in internal, or change in enthalpy. So for CV naman, delta T, that is to get the internal energy. So very important din. Okay. So given tayo ng properties na ito, natin sa kabila. So P1 and V1 are given. V1 is 1.133 cubic meters. V1 natin is 690 kPa. Given tayo at second state ng T2 naman. So T2 natin is equivalent to 555 degrees Celsius. Kapag rust. Okay. So what is next? So we have mass. Given ba si mass natin? Hindi. Okay. So, ang gagawin natin dito, since walang naman, MCV and MCP delta T para makuha si internal energy and the enthalpy is kukunin lang natin and this change in temperature na kunin lang natin si T1 and since given naman na yung ating T2 and since wala tayong 1 dito mas ano natin pwede rin ito pala ay given pala si mass natin if 5 kilogram of this gas go reversible non-flow so given pala tayo ng mass ng 5 kilogram. Ayun. So let's get the temperature one sa ating first state. So ating bagong formula that is PVMRT. Therefore temperature for T1 will be equivalent to PV all over MR. Okay, diretso na natin. We have 690 kilonewton per meter squared multiplied by volume natin that is 1.133 cubic meter. Mass natin ay 5 kilograms multiplied by the R natin. So, ano yung R from the given? We have 320 or 0.32 kilojoule per kilogram. Or kilojoule is kilonewton meter all over kilogram Kelvin. Okay. So, by unit analysis, makakasa si kilogram. So, meter squared will omit this. Magiging 1 na lang yun. So, makakancel naman dito meter. Kilonewton will cancel out and degree Kelvin will aakyat yan. So, T1 natin is equivalent to ilan?
488.6063.
Pas na. 488.6063
6063.
degree Kelvin. So, for letter B, unang tinatanong dito is find the change in internal energy. So that is MCV delta T. So na, the next. So our delta U, change in internal energy, we have MCV delta T. Diretso na natin. We have 5 kilogram of this gas multiplied by the CB natin that is given from the problem 0.84 kilojoule per kilogram Kelvin and multiplied by the delta T. We have, ito yung medyo for others is nalilipot or parang na-omit nila, nakakaligtaan nila. So delta T yan. So ito, 555 degrees Celsius pa lang yan. So kailangan natin i-add dyan si 273 para maging absolute temperature and maging Kelvin. So ayan yan. So 8, 2 plus 1. So that is 828 Kelvin. So 828 minus yung nakuha nating T1 before ito. For 88.6060. So don't forget to convert first to the absolute temperature. Lalo pag sa delta T na part or in getting the PVMRT, kailangan absolute temperature lagi. Or absolute temperature lagi ang makukuha natin if we're solving for temperature. Ayan, so paki-solve naman to. That is 663. Kelvin. So, for unit analysis, consist kilogram and Kelvin. That is kilojoule, that is a unit for energy. Then for our change in internal energy is figure
1425.4535.
1425 point.
4535.
Okay. Kilojoule. Ayun. And lastly, bago tayo mapuntang processes, meron tayo mga yun. A change in enthalpy, that is MCP delta T. We have 5 kilograms multiplied by nakuha natin R or CP pala. CP plus R 1.16. Kilojoule per kilogram. So, yun na lang. So, kaya lang 828.488 or minus pa rin, minus 488.6063. Kelvin. So, cancel. Ilan ang ating change in enthalpy.
1968.4835.
4835 or
Yes, sir.
okay. Thank you, Mr. Sendayan. That is kilojoule. Ayun lang. So, any questions for our specific heat and specific heat ratio? And so, kailangan nating daanan talaga before tayo mapuntang thermodynamic processes. So, this is one fundamental aspects for thermodynamics, the specific heat. Gagamitin nyo pa rin ito hanggang thermo 2 and so on. Pero sa thermo 2, hindi gaano magagamit specific heat ratio. Ito magagamit yung specific heat under ito, CV and CP. Specific heat ratio kasi is for ideal gas. And thermo 2 mainly involves water kasi two-phase substance, pure substance. Minsan nga, three-phase from ice to or solid ice, maging water na liquid and then gaseous state. Anyway, since we're talking about air for now, and sa term 1. Okay, are there any questions? May mga di ba nakapag-screenshot muna? Paki-isabi. Ilagay ko kung anong slide.
Sir, sa may last page.
Last page lang. Okay. Ay, mas to ah.
Thank you, sir.
Okay. Okay na. Punta na tayong thermodynamic processes. Sige. Ayan. So let's start. Kasi it's thermodynamic processes. So ito kasi sa thermodynamic processes, combination nga sabi ko ng pag-aaral natin from T1 hanggang T2. Kung maalala nyo or dala nyo notes nyo sa T1, yung mga energy, gano'n, di ba? Kung maalala niyo. Internal energy, work, kultura. So, lahat yan mag-fall under dito together with the specific heat and others, ideal gases, laws, so on. So, and let's define thermodynamic processes. So, this in are given into your modules, and then later on, arrowheads. Or, isentropic. Minsan lang naman. So, definition ng give me 5 minutes. May step size of the receiver. Okay, so balik tayo dito. So it is defined as whenever one or more of properties of a system change, a change in the state of the system occurs. Now, yeah. So the path of the succession of states through which the system passes is called the thermodynamic process. Yan, sa modules nyo to. So one example of a thermodynamic process is increasing the temperature of a fluid while maintaining a constant temperature. And so another example is increasing the pressure of a confined gas while maintaining a constant temperature. So sabi dito sa inyong module, galing sa module itong impose hanggang sa ito lang naman pala. So merong 4 processes na binigay sa module. Meron tayong isothermal, isobaric, isochoric or mas nagamit ating term na to as isometric. Isometric. Diba nasa next pages naman. And then this is adiabatic or isentropic naman. So under isothermal, constant temperature yan. ISO is constant. And then thermal is temperature, obviously. T constant and temperature na constant. So for any ideal gas, the internal energy is 0 daw. We have isobaric, constant pressure naman yan. We have isometric or isochoric, constant volume yan. So, walang work na nagaganap dyan. 0. Na-discuss or na-formulate din natin to nung Friday. And the adiabatic or isentropic. So, dito kasi is walang walang entropy. Kumbaga, entropy is constant for adiabatic. Therefore, since walang change in the entropy, kumbaga. So, parang temperature tends to go constant din. Or so walang flow of energy dyan. Kumbaga, it is insulated. Kumbaga, insulated siya. So, sa isentropic. Consequences, delta U is work. Since delta U nga is work plus heat. And since isentropic nga is no heat flow, usually 0. Pag naging 0 yan, obviously, work plus 0 lang. Which is delta U plus work. Anyway, to further discuss these following processes, ito muna pala. So there are, kumbaga, 3 different types of processes. Meron tayong reversible and irreversible processes. So summarize na to or summary na yung nasa module nito. Dinifine kasi yung mga verification sa module. Reversible and irreversible processes. Isa ko na. So it is one in which both the system and the surroundings are returned to their original state. Yun yung reversible. So, irreversible naman, otherwise, it is an irreversible process. Pag hindi mo maibalik sa dati niyang state yung ating system or surrounding, that is an irreversible process. Reversible, kaya nga kasi nga, pwede siyang punta sa state. Kasi same time, bumalik lang din. That is reversible. Next is cyclic. A process which gives the same states, conditions after the system undergoes a series of processes. Ito na yung kumbaga thermodynamic cycle. Cyclic processes is the combination of 2 or more reversible processes. Kumbaga, the cyclic processes. And lastly, quasi-static process. It is one in which system departs from state only infinite stimuli at very instant. So let's first go to isometric process. So it's an internally reversible constant volume process of a working substance. So it is under constant volume. Constant volume. So V is equivalent to C. So that is under the Gay-Lussac's law. So pag constant volume, we have here the combined gas law. So that is PV, P1, V1, P1. Combination na to ng ating mga gas laws. So that is P2, V2 over T2. So if constant ang ating volume, so magiging equal si volume 1, volume 2. Therefore, pag cross-multiply mo si volume 2 papunta dito. So since same value yan, parang magiging 1 lang silang pareho. So we can omit them, giving us the Gay-Lussac's law na P1 over T1 equivalent to P2 over T2. Okay. Yeah. So una nating malalaman for at our isentropic isometric process is on how to draw the PV and TS diagram. So, sabi ko nga doon from modules 8 to 10 natin, yung mga ginagawa nila doong diagram is PT, Pantura. So, our most common diagram is the PV relationship or pressure to volume relationship, and TS diagram, temperature to entropies relationship. So sila ang mag-partner kasi sila ang mas related. Kumbaga, di ba? Under pressure, kasi we have a cylinder, madalas if we are pumping or increasing the pressure, greatly nag-affect yun sa volume, di ba? So if we're putting more pressure, nag-compress ang volume, then at the same time, if we're expanding the volume, madi-decrease the pressure. Lagi siya, kumbaga, is directly proportional yan. At the same time, sa TS naman, direct proportional din si temperature and entropy, hindi na mapaghihiwalay. Lalo, isa siyang fundamental law ng thermodynamics. Kung matandaan nyo, it is under the third law. Ano na yun? So, parang the entropy will not go down. It just goes up or stay the same relative to the temperature. That is the third law of thermodynamics. Kaya lagi magka-partner yan sa diagram, si PV and TS. So under isometric or constant volume, so obviously we will have two states. So an process is a system undergoing initial state to its final state. So we will have only two states here. So let's say, for example, we have state 1 here in a certain point. So under isometric process, constant volume, at some point na change ang ating pressure under uniform volume. So let's say, yan, under uniform volume, or straight line yan. Let's say this is 0.2. Yan. Yan. Ganyan lang. That is for our PV diagram. Change in pressure lang yan kasi constant volume. Anyway, mas ma-appreciate nyo ito pag cycle na siya since 1 to 2 and then another 2 to 3, and 3 to 4, somewhere here in the X or PN the axis is natin. So for TS naman, since constant volume siya, usually we're having curved lines here. So let's say, for example, this is your point 1. Somehow dito yung point 2 mo. So hindi yan straight line lagi since ayun nga na kung maalala nyo doon sa modules 8, 9 to 10 kung nabasa nyo, di ba? Meron tayo dito kumbaga curve na gano'n. Ito yung common nating curve. Maalala nyo dito yung critical point, di ba? So this is, yung doon is PS ata or PT. So, kumbaga ito yung curve na yun, si TS natin. Laging, kumbaga pa ganun. Laging curve line si TS under isometric and isobaric processes. Parang ganyan. Okay. So, for the formulas, ito na sinasabi ko, puro tayo formula dito. Puro tayo memorization of formulas. So, first is for the work, yung mga work natin. Sige, ito na lang. Kasi natin dito kagad. So for our non-flow work, meron kasi tayong, diniscuss ko din naman sa, I don't know if P1 or P2, meron tayong two types of work, di ba? Si work steady flow and work non-flow. So, non-flow work muna tayo. Control Z Jetsin. PowerPoint. Non-flow work. Kung maalala nyo, nasolve natin to doon sa nung Friday sa specific kit under constant volume. So sa non-flow work kasi it is ilagay natin. It is the integration from the upper limit to lower limit. Kumaga state 2 to state 1 ng pressure and the change in volume or PdV. So since in this type of processes, it is volume is constant or constant volume. Therefore, the change in volume here, so magiging same lang yan. 2 and 1 is gonna be the same. So technically, volume 2 minus volume 1. Since same lang sila ng value, magiging 0 lang si given natin. And since 0, kahit anong pressure mo pa yun, kahit anong value ng pressure mo, pag multiply mo sa 0, that will become 0. So, ang ating work ng flow is 0. Yan. So, for example, nagpa-quiz ako. And then, number 1, letter A, get the non-flow work or work non-flow for this isometric process. So, lagay nyo lang doon, 0 kagad. May points na kayo. Kung kaya ako ganun. So, next is steady flow work. Yan. Steady. Steady. Or work steady flow. Check ko ng college ganun. Work steady flow. This is with the variable of W subscript S. So, lagi din naman. So, di ba, before, for non-flow work, laging ganito, it is the PdV or pressure times the delta volume. So, for work steady flow naman, it is the inverse of the other. So, meron tayong limits 1 and 2. This is ko naman V dP or volume multiplied by the change in pressure. And lagi yan. Any processes or maski yung dun sa in general formula sa modules 5 at or 4. So therefore, sa mga other processes, ganito lang din siya. Work non-flow and work steady flow. Yan. General yan. So, elaborate natin si work steady flow. Walang sa wala. Steady flow then, the equivalent to the volume multiplied by P2 or P1 minus P2. Negative to negative. Negative P2. Or we can say work steady flow. Is B multiplied by Q1 minus Q2. So let's use this as our general formula. Box ko na lang para madaling matanda. For the formulas natin. Pwede kayong gumawa ng index card then sulat kayo ng mga general formulas dun for the following processes. Next is the change in internal energy. Change in delta U. Change in internal energy. So the na-discuss naman natin doon sa specific heat na problems. So the general formula for this is M CV delta T. Next is change in enthalpy naman. So delta H. So kahit processes din to, this will always be MCP delta P. At the same time, ganun din si change in internal energy. Laging MCV delta T. Any process. Next is our heat transfer or heat or Q. Q mismo. Q. So we can say that Q is delta U. From there. And then, kasi ay no, explain ko na, di ba? Since ang ating Q is interchangeable naman eh. It is delta U plus work and flow. And since from the beginning, work and flow is 0, so this will become 0 lang din. And therefore, Q is equivalent to delta U. Or in some cases, mas malaki si internal energy rather than heat. So this is delta U is equivalent to Q plus work and flow. Since 0 nga si work and flow. Yeah. So lastly, meron pa. Ito na lang. Ito na lang. PF, we have we change in entropy naman, or delta S. Small s lang yun Naging malaki din. Pwede rin naman malaki. Pag mag-solve. So, the general formula in getting the change in entropy is mass CV. So, ln, this is under logarithmic functions na. Ln of T2 all over T1. Yan galing. Yung formula yan. Galing siya sa mga delta S. Derivative siya kasi is the change in heat. It is directly proportional kasi change in heat over the period of time. Ayan. So, dinerive lang yun. Nakuha to. Okay, so please take time to screen cap the following. These are your general working formulas for isometric process. Okay na?
Yes, sir.
Okay. So next, we go to isobaric process. This is naman yung pressure naman natin dito is the one na hindi nag-change or constant. Okay. So, basahin lang natin. Isobaric process is an internally reversible constant pressure process of a working substance. Kagaya siya ng Charles law. Once again, if we have the tawag dito na ulit, the combined gas law, combination of all gas laws or the main gas laws. So V2, V2 all over V2. Ayun, I so get left hand side. Right, good. Yeah. Basta pag naging ano kasi to, constant, parang makakansel lang yun. Matitira si Charles law. In which it is V1 over T1, which is equivalent to V2 over T2. Okay. So under constant pressure, we can draw. Sa ano naman, in problem solving naman, hindi gaano kayo nahanap naman PV and TX diagram for processes. Usually, hinahanap PV and TX diagram pag under cycles na siya. So for example, diesel cycle. So diesel cycle kasi is constant volume. Tapos magiging constant volume, then magiging isentropic, constant entropy, then constant pressure siya. Yun yung pag-expand or SPSV kasi. And then isentropic ulit. Okay, so for isobaric, let's say we have dito lang din ulit. Sa bandang gitna. Ay, dito na lang. Let's say this is your state 1 or point 1. Let's have PV. It's your axis. This is so under constant pressure, syempre hindi mo bago yung height niya. So, kahit saan naman dyan. Let's say for example that is state line. Then, napunta tayo dito. Point 2 na yun. Point na ito. Point 2. Since under isobaric siya, hindi nag-change yung kanyang pressure. So, straight horizontal line lagi ang PV niya. So, for TS, ganun pa rin. Curve line pa rin. Kasi for example, dito lang. Yung point 2. So, 1, 10, 1, 2. Curve lang. Mari, curve yan. Mari dito na yung point 2. Ayun. The general formula, sabi ko kanina, for work, or kumbaga nagva-vary lang yun sa, so for the general formulas kasi, technically pare-pares lang yan. Kaya nga nung na-discuss ko from P1, yung mga Q is equivalent to delta U plus work, not to control. Nagva-vary lang sila sa process. Since, for example, dito sa isometric, ito, this forward man flow, para-parehas yan na PdV hanggang sa isothermal and isotropic, yan pa rin yan. Nagkakadalihan lang sa kung ano yung constant. For isobaric, our work and flow, para natin is non-flow work. So, WN. And is equivalent to we have upper and lower limits. That is pressure, dV, or the change in volume. So that is P multiplied by V2, our low upper limit, minus V1. I-rewrite ko na lang ito. Work ng stove. Is equivalent to is multiplied by V2 minus V1. That is for work ng stove. General formula lang din. General formula. Work ng stove. Next is work steady flow. So I believe kung lang, kung formulas and principles lang mag-discuss natin for thermodynamic process. And then sa Friday na lang yung examples from the different kinds of processes. So 9 na. Let's extend for 20 minutes siguro or less or lesser. Okay. Steady flow. Diretso ko na. Bilis natin konti. Steady flow work. So, ayun nga, gaya nung kanina, sa ating isometric, ang ating steady flow work is the integral of delta P V. Ayan. So, the delta P or delta PV at lower and upper limits. And since the pressure is constant, ayan, so para magiging zero lang din yan. Parang explain ko sa ating isometric. Since ang ating P2 is magiging equivalent, so ating P1 magiging zero lang yan. Since nag-vary dito from upper to lower limit is pressure. And kung ituloy lang natin to, so that is negative to lagi. Negative V or negative V dV. Ituloy natin to, magiging negative V minus P2 minus P1. And since same lang yan na parang magiging zero lang yan. So 0 times negative V is always 0. So for work steady flow under isobaric processes, our work steady flow is always 0. So kabaligtaran siya ni isometric process. Then sila ang laging dikit or sila ang parang interchangeable lagi. So magkabaliktad din sila. So under steady flow work, 0 siya. The isobaric. Pero meron siyang work on flow. While isometric naman, 0 ang kanyang work ng flow and work steady flow naman yung meron siya or may value. Okay, let's proceed. So naman next is the internal energy, change in internal energy. Okay. So yun pa rin, hindi na magbabago. That is mCV delta P. Okay, fine. Sulat ko, ganda niya yung sulat niya sa notes. Next is CFC. Next is our change in enthalpy. Pin na yan lagi. MCP delta P. Next is our heat transfer or heat lang. Heat transfer. is Q equivalent to delta U plus work. Flow. We can say na delta U plus T delta P. V delta P property. Anyway, basta ang ating heat technically is delta H. It is just the same. Kumbaga, sa ating isometric, ating heat is same as the internal energy, which is CV delta T. Ito, di ba? Isometric kasi siya, so, kumbaga, di ba, constant volume. So, ito is sa insight ko lang, sa aking, sa utak ko lang. Since isometric siya, nakakuha naman natin yung process dito. Since work na flow is 0, therefore this is equal to delta U. And yun ngayon sa CP, since yung drawing ko na stem, at napapasok na heat sa CP, then delta U. So since walang nag-escape or hindi nag-flow, technically nagiging Q is delta U under isometric or constant volume siya kasi. Constant volume process. So under isobaric naman, and CP, and dito sa delta H ang na-affectuhan ng CP. Like dito kay isometric, yung CV natin is na-affectuhan ng S yung sa delta U. Under isobaric naman, ito naman. It's constant pressure process siya. CP. Anyway, if hindi mo makuha yung enthalpy, pwede yung gamitin tong ating general working formula din. Delta U plus work done. Since if nasolve natin yung ito, madaling solve yung MCP delta T, we can use na lang this easier way to solve the heat transferred. Anyway, let's move on sa last, ang ating change in entropy. So for change in entropy, same lang siya. MCV or MCP naman ito since this is constant pressure. Log of P2 all over P1. Function out is change C V. So from isometric, ating change in entropy is CV kasi constant volume. And dito naman sa isobaric, change C PV into CP since this is under constant pressure. And those are the general formulas for isobaric. Screenshot nyo na lang. Then, nakita nyo kung tapos mo ng screenshot. Is lahat? Okay na?
Yes, sir.
Yes. Okay. So, next isobaric is our isothermal. So, it is an internally reversible constant temperature process of all these substance. Kumbaga, magiging Boyle's law siya. Is P1, B1 all over P1 is equivalent to P2, B2 all over T2. Since temperature constant na, so nagka-cancel lang si temperature, kaya magiging ganito yung relationship nila. Boyle's law. Under isothermal, let's try to draw DPB and TS diagram. Pero under processes naman, sabi ko hindi siya kakailangan like sa cycle. So since constant temperature siya, ang kumbaga hindi gagalaw yung height niya. ng ating temperature. Okay, so this is the point 1. So, laging straight horizontal yan. So, this is our point 2. Ayun lang. Constant temperature, meaning hindi nagbabago yung y-axis natin. So, under PV naman, it always goes from curve line lang din. Let's say we have these 2 points. Okay. So, pag ganun lang siya. For phase 1 and phase 2. Okay. So, going or moving forward, we solve for our workman flow muna ako. Workman flow. Flow. Okay. Hindi na yung magbabago na flow work is equivalent to PdV, or you can write here as workman flow is equivalent to pressure multiplied by V minus V1. Okay. Next is work steady. For work steady flow, work steady natin is ganoon din. Pag ko dito is integral of VdP naman. Nagbabari si pressure. So this is technically V into V1. Better pala ito. Or since sa isothermal tayo, meron palang special case. Since PV is constant dito parang PV is constant. You can see the PC is PV and then so basta ang pinapalitan ko dito is we can also write our work and flow. May bagong general formula ito, it is V1 kasi nga constant yung PV natin. Log of V2 over V1. Ito ang memorize mo. Or we can also see. Kalimutan nyo na to. This is applicable para for isometric and isobaric. We can also write work and flow as MRT. Mapansin nyo, PV is constant natin. So, PV is equivalent natin sa MRT. So, that is log of V2 over V1. Post ko na lang ito para nakakalito. These are the general working formulas for workman flow. Pwede mo mag-pause sa book. And for work steady flow naman, kalimutan na din natin ito. Masakit pero kailangan. For work steady flow, kumbaga we have PV, it's equivalent to C. And then, since ang nagbabali dito is C o volume ang ating, ito kasi diba, ito, nagbabali si volume, so parang P natin dito, CD. Ito naman is CB is equivalent to Q over P. Blah, blah, blah. Kanyang work steady flow naman is parang magiging ganun din since PV is constant. So PV ln of V2 over V1. Ganun din. Or ganun din sa kanina. Work steady flow is yung RT ln of V2 over V1. So what is the relationship? To summarize the relationship of in the isothermal, work steady flow is equivalent to work non-flow since PV is constant. Tandaan nyo nga lang yun. So pag tinanong sa problem is, what is the work steady flow given that the work non-flow is ganito? Ginawang bonus yung question. Ayun lang. Letter C. Tayo. Change in internal energy. And that is 0. And then our change in enthalpy is also 0. So bakit 0 yung mga yan? Kasi we're under isothermal processes. Since ang kanilang general formula, di ba, is MCV delta T. Delta T. So, ang ating process is constant temperature. So, parang ganun din sa ating PDB. So, if we're dealing with the change in temperature, since T2 is equivalent to T1 in this process. So, pag M, kahit ano, i-multiply mo sa MCV or MCP na delta T, kung parehas naman, magiging 0 lang din to. Magiging 0 yung delta T natin. Therefore, 0 lang din yung delta H and delta E. Okay. Letter E, we have the heat transfer or simply heat. So sa heat naman, since this general formula here is delta U plus work, either steady or non-flow, but commonly it is work non-flow. Since given na ang ating delta U is 0, so yeah, 0. We can say na our heat is equivalent sa ating work. This is the general formula for heat or Q. And then lastly, our change in entropy. Change in entropy is MR. R ln of V2 over V1. Then, V1. Ito yung ating formulas for isothermal. Next, isentropic naman. Under isentropic, from point 1 kasi, this is isentropic is constant. So isentropic is an internally reversible constant entropy. So S is constant of working substance. So it is also known as the reversible adiabatic process, meaning there is no flow of heat between the system and surrounding. So Q is 0. So let's try to solve draw the diagram. So PS. So hindi magbabago yung ating x-axis for the t S diagram. Since S is constant. And so say this is your point 2. Ganun lang. Same lang rin sa PV natin. Kasi this is 1. Then this is 2. Curved line lang din siya. Yes. Ganito lang. So, dito is ganito kasi yun. PBK. Yung constant natin dito is yung PV over K. So, we can say na ito, P1, V1 raised to K equivalent to P2, V2 raised to K. Matanda niyo yung relationship na ito. Under, lang itong under effect lang ng K is CV. So, hindi siya enclosed sa parenthesis. So, CV ang apektado ng heat ratio natin or yung K natin. Ito na nag-apply si specific heat ratio. So, another relationship is temperature to volume relationship. That is T1 all over T2 is equivalent to V2 all over V1. Ito. Is to K minus 1. And then lastly, the temperature to pressure relationship naman. So we have T1 all over T2 is equivalent to T1 over T2 T raised to K minus 1 over 1 and over 3 pala. Yan. So, sa ulo nyo to. The relationships. So this is pressure to volume relationship and there's entropic process. Temperature to volume relationship for isentropic. And temperature to pressure relationship and their constant entropy process. So pakiscreen siya. And then we will go over the next or the mga work natin. So let's have this is the relationship between properties. So this is the general working formulas. So this is lang din, equations or formulas lang din regarding the properties. This is the general formula naman in order to get the ating mga work and energies or heat. So work ng flow natin. Ang formula natin for work ng flow is P2V2 minus P1V1 dito. Baka natin ng iba is general energy all over 1 minus Q. Or we can say since PV is equals to MRT, we can say that MR P2 minus P1 all over 1 minus Q. So either of these pwede nyo gamitin to get B, work na flow, under isentropic process. For steady flow naman, ang shortcut for work steady flow is K, work na flow. Technically, parang may K lang tayo dito sa unahan. B2, B2. B1, B1. Oh, okay. 1 minus 3. So this is equivalent to, parang maglagay lang tayo ng K sa unahan yung MR. Ito ay. Over 1 minus 3. And that is for work steady flow. So any of this formula will do in order to solve our work steady flow. Letter C, ang ating internal energy or change in internal energy. Delta U. For delta U, ano mga nagbago dito? That is still M, CV, delta T. Yan. Or since heat is 0 dito, we can say na this is negative work na flow from heat is equivalent to 0. Ito nga meron tayong formula na heat is equivalent to delta U plus work na flow. Since heat natin is 0, parang kinaskusan natin si work na flow sa kabila. Delta U is equivalent to negative work na flow. So any of this will do in order to get B. Delta U. If meron ka ng work na flow, ibigyan mo yung delta U. Kumbaga. Next is yun siya enthalpy. Okay. So gawin pa rin yun. MCP, delta T pa rin. Then for heat, and heat is 0. Is 0. Then lastly, our change in entropy is also kasi nga constant entropy or adiabatic. Okay. Yan, paki-screenshot na lang, mabilisan. Okay na? Okay na ba? Wait ko kayo this check ko natin next. Meron kasi pa tayong last. Yung sabi ko nga, this is under yung module lang ng isentropic. Pero meron pa tayong polytropic process. Anyway, this will be discussed sa Friday na lang since nag-overextend na tayo. So let me just check the attendance na lang. Mr. Aquino.
Present, sir.
Okay. Okay, Mr. Arenas. Arenas. Okay, Arenas is present. Si BI.
Present, sir.
Kagiwa. Carpio. Carpio is AFK. Marvin De Luna. Mr. De Luna. Sabi ni Mr. Aquino pwede isend yung PDF. I-send ko yung PDF but technically kasi blanco yung PDF eh. Diba?